Good night, everybody. Tonight we have a third degree polynomial with a missing coefficient, namely the coefficient of the linear term. Now, any third degree polynomial has up to 3 zeros or 3 roots, and so I'm gonna label those A, B, and C. Mathematicians are just alphabetical order junkies. All right, so these are sometimes called roots also. More frequently called roots these days, I think. Okay. Now notice B is what we're looking for. We're given the product that 2 of the roots is 1/30. Again, we have no idea what the roots are, but we know the product of 2 of them is 1/30. Okay, so we're supposed to determine this value of B. Now, there's a well-known result in algebra that says if you have a 0, you have a linear factor corresponding to that 0. It's called the factor theorem. So x minus a is a linear factor owing to the fact that a is 0, and similarly for the rest of these guys, folks. Now, upon expansion, you get this interesting result right here all by itself. This is called Vieta's theorem, right? This is just third degree, but you have minus the sum of the zeros as the coefficient of x squared. Whatever the zeros are, negative the sum of them will appear as the coefficient. It's called Vieta's result. Formula, some people. Now, this one's not quite as obvious, but you have each of the roots as products of pairs summed together, okay? So this is not crystal clear why this would happen unless you just expand this out yourself. So you guys can do that on your own if you don't believe this. And it's pretty clear that minus the product of the roots is going to be the constant term, okay? So let's see how we can use this given information right here that the product of 2 of the roots is 1/30. Now, what we do to get started on that is actually equate coefficients. Notice how I wrote down a plus b plus c is equal to 107 over 210. Well, that's because minus a plus b plus c is the coefficient of x squared, but we have minus 107 over 210. So the minus signs just go away, right? And you have a plus b plus c is 107 over 210. Okay, so we know that. So we have one equation, 3 unknowns. Not much to go on just yet. Now, also in a similar fashion, b is the coefficient of x right here, and ab plus ac plus bc quantity is the coefficient of x down here, so we equate b, and in a similar fashion, abc is equal to 110. Notice the minus signs just kind of disappear because that's just the way it is. If there's 1 here and there's 1 here, then abc would have to be 1 over 210, all right? Now, so how can we use the given information? We know that product of 2 of the roots is 1/30. Okay, so I arbitrarily let the product A be. There was 3 choices for 1/30. I could have put it here, here, here. So this is a standard without loss of generality where people wave their hands, which is what I'm going to do. But it doesn't make any difference because of the symmetry. And that's what everybody says, and it's never real clear what they mean. But I think everybody intuitively understands you don't have enough information. You don't know which one it's going to be, so just arbitrarily pick one. And a good exercise, if you don't believe it, is to try it for all 3 cases and see that you get the same thing. I'm not going to do that here. All right, so now right here, I replaced the AB with 1/30. Notice that AB is right here too. And so I wrote 1/30 here and then wrote it as C over 30. But this certainly implies that C has to equal to 1/7. Okay, right here, this C is equal to 1/7. And that's some easy arithmetic, right? Okay, multiply through by 30, you get 30 over 210. Which reduces to 1/7. Okay. Now the next line will just be putting C. And so far, this is the only 0 we're going to know, I think. You'll see how this goes. It's kind of cool. So C is 1/7. All right. So I just placed it right there. And also right here, I sort of left out a step here. C is 1/7, but it's common to A plus B, so we can write this in this fashion. Okay. Now, how about right here? Okay. So if we knew what A plus B was, we could just substitute it here and be on our way to finding B, right? So let's do that. We have A plus B. Now we need to subtract 1/7 from both sides and make it an equivalent fraction with a 210 in the denominator. That would be what? 30? Yeah, that would be 30 over 210 is 1/7, right? 30 over 210 is 1/7. So if you subtract 30 from both sides, you get 77 over 210. Okay? Now right here, folks, we're just going to physically take the 77 over 210, place it right here, and then do a little bit of simplification at the same step. So we'll end up with 1/30, okay, plus, now a plus b we've just shown over here is 77 over 210. If you divide that by 7, you get an 11, right? And so you would get 11 over 210 right here, right? Is that making sense, folks? And remember, this is our b. So after we do this computation right here, we'll be done. So let's see. Multiply this by 7. Wouldn't this be equal to, folks, 18 over 210? Again, y'all, the common denominator is implied to be 210 right here, and then 7 right here over 210. 7 plus 11 is 18. Now, you can tell that this is divisible by 3 by the sum of the digits test. So if you divide, in fact, it's divisible by 6. 6 times 35 is 210, right? And 6 times 3 is 18. So we get right here that this is equal to 3 over 35. But remember, this is our b, right? So we found the answer, folks, and what's to me is still amazing about this is the only 0 that we really found was c is equal to 1/7. And I'm not even sure, I guess you can go back and find it, but it's not clear what the other zeros really are, from where I stand. We know that c is equal to 1/7, and we know b is this, but we never found the zeros a and b. Okay, so maybe it's right in front of me, but I don't think we can find them very easily, if at all. We could do the rational zero thing and go through all of that, right? But from here, from this vantage point, it doesn't appear like we can find the other zeros unless we use some other results. Okay. But anyway, we solved what we set out to solve. We're finished with the problem. B is equal to 3 over 35, which was what we were trying to find. B is equal to 3 over 35. And that completes the problem.